Hey, how are you? So, a well-known fact that Rust is really fast. And I had this one specific case where actually Rust wasn't really faster than, well, some of my Python implementation of the same algorithm. So over here I'm showing my tests that I did in regards to accessing a few parameters or values inside a hash map or a dict in various languages. So I wrote the same algorithm in Python, Rust, Go, and JavaScript. You briefly saw it here. The hash map is actually quite simple. There's like a key and a boolean in there, and the JavaScript code that accesses it is quite simple. We have a number of iterations that we repeat the same accessing stuff over and over again, and we have a few keys that we are interested in. So this is this, and we just read whatever is the state of that dictionary, whatever is in there. In JavaScript, the same code in here, same keys, same world state, same iterations, same accessing without checking if the key is in there. Same in Rust, same keys as here and here. Same iteration stuff, same accessing data without actually checking if there is something in there or not, and not creating unwrap thing. And obviously Go, this is pretty much the same thing. I just wanted to see if it behaves in a fast manner. So I ran the thing in multiple iteration like ranges. So this and this, sorry, this and this, which are the same pieces of code, are reflected here. So these are the iterations, right? So the same operation for 10,000 iterations for Python, it takes one something milliseconds. This is time in milliseconds. For 10,000, of course, it's 10 times more. It's 12 milliseconds, and now it's in what's it? A million, or is it 100,000? Yeah, it's a million. It's this, and then it turns into a bunch of seconds. So this is 1.238 milliseconds. Sorry, this is 1 second and a bit more. For can I count? For 10 million and for 100 million, it's like 12 seconds, which is interesting. If you read the values in here, Rust is not the fastest. Rust is like third. So the first one with the same operation was actually Go. Then somehow JavaScript got faster. Then Rust was faster, and of course Python was like really, really, really slow for this case specifically. And this case is important for me because this is a part of goal-oriented planning where the actual object could be highly configurable. I could add more values to the world state or decrease the size of world state, right? So this is highly configurable thing, and I kind of want to work with Hashmap or dict or object or whatever. So this is important for this specific case, and my goal-oriented planning was successful in Rust, which I showed on the channel before. So here you go. Apparently, if this wasn't about hash maps in the algorithm, of course, I would guess Rust would be like way below here. It would perform the 100 million operations faster than Go, or at least it would be faster than JavaScript. I haven't checked that. Now, I'm not looking at the amount of memory these faster approaches, which is JavaScript and Go. I'm not sure how much more memory they use than Rust, because since Go, JavaScript, and Python are garbage collected, they do keep track of indices they access the most, so there's some manipulations, I guess, that take place. This is probably why JavaScript somehow outpaced the Rust implementation, which is like really raw access data by key. But this is interesting to see. Now, realistically, other than my goal-oriented planning thing, it yeah, in my goal-oriented planning algorithm, Python actually outpaced Rust implementation for some reason, and I'm not sure why. So there you go. And just to say a few things, like there's a bunch of people on the Reddit also post that for some reason Rust is kind of slow with hash maps, and in Java hash maps work faster than in the Rust. So Rust also admits that their implementation, although it's safe, it's kind of slow, and they suggest you to go to other crates on like to get a faster package to work with hash maps. But the thing that I take from this is apparently, well, my day job is in TypeScript, so I'm doing the right thing by sticking to it for my work. As for Rust, obviously I need to rethink how the context for the algorithm should be structured so that it doesn't rely on keys and works with indices or references or anything else. Python, it was the easiest thing for me to write, like, period. It's that simple, and Go is just Go. It's like semi-Rust and semi-JavaScript, so it's kind of annoying to write in it, but it's kind of simple, I guess. Uh, as for benefits of Go implementation, well, since it's almost like JavaScript in its implementation, or TypeScript rather, uh, yeah, I bet it consumes less memory in RAM than Node.js application, because the only infrastructure that this executable would need would be just Linux or Mac, but this would need to have um, actual node runtime, which consumes 20 or 40 megabytes of RAM by just printing hello world. So yeah, there's my rant. Stupid waste of time, but for data crunching, maybe JavaScript is a bit more useful when you rely on keys more than actual indices. Yeah, but Python is still fast, inconceivably faster than human read and processing speed. Well, look at the chart again. Python turned out to be kind of slow. Rust is alright. JavaScript, incredibly fast for this specific use case. And Go is just amazing, but not that far. Um, yeah, again, not looking at how much memories they actually use to perform this way, but nonetheless, it's impressive for all the participants over here. And yeah, by the way, subscribe maybe. Cheers.